Okay, so we've got another radical equation, and this one seems a little bit more difficult, but we're going to make use of this fact right here, the binomial squared property. And in doing so, this is going to help simplify this process, and we'll make this problem a little more manageable. Okay, so what we want to do, of course, is square. But we can't necessarily do it right away. I mean, you could, you just make your life a lot much more difficult. So what I'm going to suggest when you're solving this is isolate the radical. All right? So you want a radical, one radical on the left, and in this case we've got two radicals, so let's put one radical on the right. And in doing that, let me write this in a different color so I can show you that we are actually adding it to this side. So there we go. It cancels here, and we are left with something that looks like this. Square root of 2x plus 3 equal 1 plus the square root of x plus 1. And this, well, let's keep going. We want to square both sides now so we can get rid of at least this radical. That's going to give us 2x plus 3. But guess what? We have a binomial of sorts. So here it is. We're going to square it, and we're going to get something that looks like this. So we've got 2x plus 3 on the left. Now the right-hand side, we square the first term, which is 1. So that stays 1. And then we're going to take 2 times a times b. So 2 times 1 is 2, and then times this radical. So plus 2 square root of x plus 1, and then we're going to finally square our b term. And this guy's our b term, but what happens when you square a square root? You get rid of that square root. So this is plus x plus 1. So you might want to pause, you might want to rewind to see what it was that I did there, but this is just a binomial squared of sorts. Okay? So I'll let you pause if you need to. Okay, now let's continue. So what we're going to do next is worry about combining like terms. All right, so I'm going to combine like terms here. Let's see. I'm going to get 2x plus 3 equal, let's call this x plus 2, x, and then 1 plus 1 is 2, plus, not to be confused with this 2 square root x plus 1. So now I'm going to move this x to the other side, and let's move the 2. All right. And the whole point here is we want to isolate again this radical. So that's what we're doing. We're trying to isolate the radical once more. So this is going to give us x, and then 3 minus 2 is 1, so x plus 1 equal 2 square root of x plus 1. Now, what we're going to do is we're going to square both sides yet again. So understand that by squaring, what we're doing here, we're introducing the possibility of creating extraneous solutions. So that's very possible here. So what we're going to do, remember at the end, is check our answers. So we're squaring this, it's a binomial squared. So again, we're going to make use of this nice property right here. And let's say that this is x squared plus 2x plus 1 equals, now when you square this guy, that's really easy. 2 squared is 4. And when you square a square root, you get rid of it. So 4 times x plus 1. All right. And then distribute. All right. We've got x squared plus 2x plus 1 equal 4x plus 4. Now it's quadratic, and I want it equal to 0. So I'm going to move these two over to the other side. And just like that, I move them, and I get x squared, not plus, in this case it's minus 2x minus 3 equals 0. So I can factor this very, very quickly. I need the factors of negative 3 with a difference of negative 2. Well, that's pretty simple. X minus 3 and x plus 1. There we go. All right, let's apply the zero factor property. X equal 3 and x equal negative 1. Okay, remember that these are not necessarily the solutions to the radical equation. We just need to keep in mind that we do need to go back and check these. So I'm going to do that up here. First, let's check x equals 3. All right, let me draw a line. X equals 3, and I'm going to plug it into the original. Square root of 2 times 3 plus 3 minus the square root of 3 plus 1, and it should equal 1. So let's see what we get here. 2 times 3 is 6, plus 3 is 9. Square root of 9 minus the square root of 4 should equal 1. The square root of 9 is 3. The square root of 4 is 2. And 3 minus 2 is 1, and 1 equals 1. So this one checks off. So x equals 3 for sure is one of the solutions. Now let's check x equal -1. All right, square root of 2 times -1 plus 3 minus the square root of -1 plus 1 should equal 1. Okay, so what do we get here? So 2 times -1 is -2, and -2 plus 3 is 1. So the square root of 1 minus the square root of 0, and that of course is just 0, should equal 1. And guess what? The square root of 1 is 1, so 1 equal 1. Another true statement. So we actually have two solutions for this radical equation here. So it's x equals 3 and x equal -1 are the solutions for the original radical equation that we started with.